Aircraft is flying away from a station on a heading of 045 degrees. No, we're on a different question. Aircraft is flying away from a station on a heading of 045 degrees. So it's question number 10. The aircraft is flying away. So what I'm writing down here on board are the key points which you have to note for any given question, because any change in these parameters can change the answer. So it's moving away and the heading is given as 045 degrees with 10 degrees starboard drift. Find the RBI reading, QDM and QDR. RBI indication, QDM and QDR. As I've told you before, sometimes the question they can give you find the ADF indication. If nothing is mentioned, ADF is always an RBI. So it is exactly the same. So don't get confused whether it is RB or RMI. If it is RMI, they will mention it particularly as RMI, or they'll probably give you the QDM, which is the RMI indication. Alright, so one thing which you have to understand is whenever a heading and a drift is given, what can you find out from there? Track. Because only then I'll be able to draw something on the board. Everything that you draw here on the chart, on the globe, on a paper is all track. Okay. Yes, so what is the track here? We have a heading of 045 degrees and we have a drift of 10 degrees starboard. What's the meaning of 10 degrees starboard drift?
The track is to the starboard side of your heading.
That's right. Track is 10 degrees starboard of the heading, and therefore, since it is starboard, track is having a higher value. Therefore, it is 045 plus 10.
Plus 10. 055.
That's right. 055 degrees magnetic is the track. What track is this? This is track of the aircraft. That could be the track towards the station if the aircraft is moving towards the station, and that will be the track opposite to the towards the station if the aircraft is moving away from the station. So don't always think that your track to the aircraft is a QDM. That will be QDM only if you are tracking towards the station. If you're tracking away from the station, as in this case, your track of the aircraft is exactly the QDR, which is opposite to your QDM. Right? Alright, so here that is it. Now let's find out the RBI indication. How will you find the RBI indication?
Moving away.
So
it's 180.
The reference is 180, yes.
Plus the starboard drift.
Since it is starboard drift, it is a plus 10 degrees, right? Which is 190 degrees relative. The NDB is 190 degrees clockwise from the nose of the aircraft. That's 190 degrees relative. Perfect. What's the QDM?
Heading plus relative bearing.
Heading plus relative bearing. What's the heading? Heading is 045 plus relative bearing is what we just found out, 190. How much is that?
35.
5 5 degrees magnetic, which is a magnetic track to the station. And therefore, what is QDR?
180 plus 360
plus 180, which is
10 and plus 180.
Yeah.
Yes. It's 415 minus 360. Yeah, 415 then minus 360 gives 055. Magnetic.
You can simply subtract 180 from 355 of 235 also. That'll give you the answer straight. So usually if this QDM is more than 180, it's always easier to subtract 180. If the QDM is less than 180, you can probably add. Yeah, but anyways, either ways you'll get the answer. 055 magnetic is the magnetic track from the station or the QDR. Right? Let's draw the diagram here. The track of the aircraft is 055 degrees magnetic. So it's always this kind of a drawing will help you to understand VOR as well. So always try to understand how to draw this. And once you understand the drawing part, then you can even find the answers without the diagram. So track of the aircraft is 055 degrees. I've simply very blindly drawn a track of 055. Now let me put the navigation aid at the center, which is right here. This is the NDB. On what side of the NDB will you place the aircraft? Right or left?
Right.
On the right side, right?
Because we are going away from the station.
That's a 055 track away from the station is here. Over here it was again 055, but it's towards the station, right? So here this is the track of 055. degrees away from the station. And to place the aircraft, now I have to look at the heading here. The heading is 45 degrees. Since this is 55, I'll place the aircraft here on a heading of 45 degrees. This is the heading of the aircraft. Right, you can see measured from the heading towards the track is what is called as drift. And what's the drift here? It's 10 degrees. Are you connected, Deepika?
Start.
Yeah, 10 degrees starboard drift, which means the track is 10 degrees to starboard of the heading. Therefore, that's correct here. Now, let's find out the indication. To find the indications of the ADF, you have to first draw this dial here. And remember, the needle always point towards the NDB, which is right here. What is the head of this ADF as an RBI? The head, which is in line with nose, is going to be 0, or nose of the aircraft. Right? Now, therefore, what's the tail? The tail is going to be 180. Right? This angle is 10 degrees, and therefore, what is this angle here? That's
10.
also 10 degrees. Therefore, the relative bearing measured from the nose of the aircraft clockwise towards the needle will be 180, so much, plus this 10. Therefore, this is going to be 180 plus 10. This is exactly what we did here. That is why we say that it's always 180 plus starboard or plus port. This is the reason. Minus port. So, which is 190 degrees relative. And how is the pilot going to see this? Dial, center of the aircraft. As an RBI, the ADF head will be 0, and the needle is going to indicate is turned by an amount equal to 190. 190 turned from 0 will indicate 190 itself. This is going to be your RBI indication. Now, what about the RMI indication? ADF as an RMI, the head is going to be the heading of the aircraft, which is 045. Now, RBI over RMI, it's always going to turn the needle by an amount equal to the relative bearing of 190. So, relative bearing of 190 now measured from a heading of 045 will give you the QDM, magnetic track to the station of 235 degrees, which is the QDM. And read from the tail of the RMI is the QDR, which is 055 degrees.